Hi there everyone. Today I would like to show you how to solve this very simple problem regarding integral calculus. In this problem here, we do have some integrals, some definite integrals for our functions. However, we don't know what the function is. And at the end, we are asked about some definite integral, which is different from those that we had before, of 4 times that function. So there are a few properties here that we have to discuss before we go forward solving this problem. The first one is, let's say that I have a definite integral of fx dx from 1 to 2, right? And another one which is from 2 to 3. As we have discussed so far, this should give us, if this is the shape of our function, it should give us the area of that function between points 1 and 2. And this second one, well, same function, right? Should give us the area between 2 and 3. So what would happen if we added those two? Well, if we think about the areas, we would then, safe to assume that we would have the area from 1 to 3. And how would we express this with a definite integral? Well, from 1 to 3 f of x dx. So the first point that we can observe here is that if we have a definite integral from a to b of f of x dx, we can split that into, let's say, a to c f of x dx plus from c to a f of x dx. Another property which will be important here is we can flip those limits here. So if originally our function, our definite integral, is between points a and b, if we invert those points, so from b to a we're going backwards, so our area in this case would be calculated to be negative because we're taking x in the negative direction. When we're going from b to a, we're going to the left, so we're counting everything to be negative. And that's another property. So simply, if we invert those 2 points here, a and b, we're going to get negative that integral. So now we do have almost everything that we need to solve that problem. The last thing is, if so assume there is an integral of f of x dx, and I'm multiplying this by a certain constant. So let's call this k. K is an integer, whatever. So if we multiply this, we can actually just get that constant inside, right? If you apply that to problems, you see that you can just solve this and multiply everything by k, that's fine. But since it's a constant, it will not change your integral. If it was x, something with x, you wouldn't be able to put it inside of your integral. But if it's a number, like in this case it's 4, you can just take it in or outside of your integral as you want. We actually did this before when we were trying to investigate, for example, what is the integral of, let's say, x squared. We thought, okay, what about this function here, x to the power 3? The derivative, right? Oh, sorry. The derivative would then be 3x squared. So we did this to find out that the integral of f of x would be dx, right? Then we can just put that inside of your integral, and we did that, right? We got this to be x to the power 3. So if we're looking for the integral of x squared, we would divide this. We would get this 3 outside, divide on the other side, so we can get the dx here, right? So x squared dx is equal to x to the power 3 over 3. So we did that, right? And we're going to do that again. So I'm going to clean this up and use those techniques to solve that problem. Now notice that our function from 1 to 9, the integral is 5. Now we can split this, since our next integral here is from 1 to 7, we could split that, right? So the integral from 1 to 9 should be the integral from 1 to 7 plus the integral from 7 to 9. Right? So it's just 1 to 7, 7 to 9. You can just follow here and you can see that beginning and at the end, they are the same. Alright, so we know this value and we know this value. This is 5, it's given, and this is 8, it's also given. So we may find this last one. So if this is 8 and this is 5, this has to be negative 3. So the integral from 7 to 9 of f of x dx is take away 3. Now, our concern here is about the integral from 9 to 7, not 7 to 9. So we will have to invert that, right? Reverse the order. So integral from 9 to 7 of f of x dx. Well, let's do the following. Let me put exactly what we have here, right? Because this is what we're looking for. Now, using what you have just learned, we can bring this 4 outside because it's a constant. So this is 4 times integral from 9 to 7 of f of x dx. So now we can make this negative. So this will be negative 4 integral from 7 to 9 of f of x dx. And we know that one. We know that this is negative 3. So this is negative 4 times negative 3. And if you multiply those two, since both are negative, then you get 12.